Hello, my dear lovely children. Welcome back. Let us continue today's journey with concept number 7, that is measurement of volume. Before starting with, let us try to define what is volume. Yes, the space inside a container is called as volume. I repeat, the space inside a container is called as volume. To measure volume, we use different types of containers, especially measuring jars, measuring flasks, pipette, burette, and many more. Generally, in laboratories, the measuring jars, conical flasks, and some other containers are used to measure some desired amount of volume, desired amount of liquids. And on this measuring jars, it will be marked accordingly in milliliters. So here you can see that this is 10 ml, 20 ml, 30 ml, 40 ml and so on is being marked, and based on that we can measure the given amount of liquid. This instrument is called as pipette and this instrument is called as burette, whereas this is a conical flask, this is a test tube and this is a measuring jar. So, to measure the given amount of any liquid, the general unit we will be using is liters. And this liter is marked for about, it ranges from 50 milliliters to 1 liter. I repeat, 50 milliliters to 1 liter. Coming to the pipette, this is how a pipette looks like. It has two holes at the two corners. Smaller one, narrower one, and here the broader one. The amount of liquid is sucked inside the pipette as if we suck some liquid inside a straw, and then the desired amount of liquid is being measured by releasing the knot. And this is how a burette looks like. This burette is generally used to measure the amount of liquid discharged. I mean the amount of liquid coming out from this tube. This is called as burette. So whenever we release the knob over here, drop by drop the liquid will comes out, and based on the amount of liquid that is coming out, that the liquid is discharging out, we will be measuring the volume of the given liquid. Generally, these liquids are measured both for irregular as well as the volumes is measured for regular as well as irregular objects. Irregular objects means something like a shape of a stone, a leaf or anything. It has no specific shape. So in order to measure the volume of an irregular object, we need to immerse the given object inside the jar, and whenever the object is being immersed, it displaces some amount of liquid. I repeat, suppose if you suspend an object inside, initially it was marked for something around 90.4, and if some object is being immersed inside, its length may increase up to say 100. Then this amount increases, whatever the volume is being, the difference in the volume whatever is there, that difference in volume is equivalent to the volume of the immersed object. Likewise, so volume of any irregular shaped body can be calculated by the amount of liquid displaced from the jar. Apart from that, if a regular shaped body is like a spherical shape or a cubical shape or a cuboidal shape, any such shapes are given, then you can directly calculate their volume using the direct formula. For example, for cube, we will be measuring as side into side into side, side cube or a cube. For cuboid, it will be length into breadth into height. Whereas for a spherical shape, we will be using the volume formula as 4 by 3 pi r cube, so on and so forth. So let us begin our numericals based on the concept. So moving to the level 1 of worksheet 7, the first numerical goes here. The space inside the container. I told the space inside the container is called its volume. So, The space inside the container is called its volume, or another name is the capacity. Volume or capacity. The space inside the container is known as its capacity or volume. Next. Dash is used generally in laboratories for measuring the quantity of liquid discharged. The amount of liquid discharged, in order to measure the amount of liquid discharged, so this instrument we are using it, and this instrument is called as burette. So let us come back. The quantity of liquid discharged is nothing but your burette. Okay, so burette, based on the burette, we can measure the quantity of liquid discharged. Moving ahead, some solids have definite geometrical shape. Yes, of course, they are called as regular shape. No particular shape is the irregular shape. Particular shape is there, then they are called as regular shape. Hence, regular solids. Solids having definite shapes are called as regular solids. Moving ahead, we measure the volume of a small irregular solid by using a overflow jar. So, amount of liquid, overflow, how much liquid has been spilled out, how much liquid has been overflowed. Based on that, we will be measuring the volume of the irregular objects. Next, liter measures capacity ranges from liter. In order to measure the liter, some unit, whatever I have said, range is there. The basic range is 50 ml and ends up to 1 liter. So, 50 ml to 1 liter, and hence your option is 1. Next, the level of water in a measuring cylinder is given to be 12.5 milliliter. How much is that? The total level is given as 12.5 ml. When a stone is lowered inside it, so when a stone is dipped inside it, initially in the measuring jar, its initial liquid was 12.5 ml volume. Initial volume is given to be 12.5 ml. Whenever a stone is dipped inside it, then its water level increased because it occupies some space. Hence, this water level increased to this extent, and now the volume value is, now the next volume, this part is given to be 21.0 ml. That means initially it was 12.5 ml and now finally it became 21.0 ml. Then the volume of the stone is difference in these two volumes only, the space occupied by the stone, and hence the volume of the stone would be no doubt that it will be 21.0 ml minus 12.5 ml. So how much is that? So volume of the stone is equals to 21.0 ml minus 12.5 ml. Difference between the two levels. And hence your answer would be how much, children? Yes, it is 8.5 ml. 21.0 minus 12.5 is 8.5 ml. Here goes your answer. Next, when a stone is lowered in a measuring cylinder, same like previous question, the volume was 9.3 ml. What was the initial volume they given as? Initial volume, starting volume was 9.3 ml. The volume of this stone, the volume of the stone itself is given to be how much? 5.8 ml. Then the initial volume of the water in the measuring cylinder is, initially they asked. Let me repeat. So here the stone along with volume. Volume means whatever the final volume is there. The stone along with volume. How much they gave, children? The total volume. This value. Stone along with the total liquid is given to be how much? 9.3 ml. The stone itself is given to be 5.8 ml. This stone is 5.8 ml. Overall stone plus liquid is equals to 9.3 ml. So this is the given condition. You are asked to find the volume of water in the initial volume of water. So let me say that initial water, only water. How much you are asked? What you are given? You are given that water plus volume of stone is given how much, children? Water plus volume of stone is equals to 9.3 ml. And volume of stone is 5.8 ml. Then volume of water is equals to 9.3 ml minus 5.8 ml. So finally, how much is that, children? Yes, it is 3.5 ml. So what is the answer? 9.3 ml minus 5.8 ml is equals to 3.5 ml. So here goes your answer. Next.